So before we go into routing, let's talk about several things that we came across. Okay, so one of those things, which for some reason this is acting weird already. Okay, um, so one of the things that we realized was the destruction or lack of communication via our span tree. Okay, so between these two switches, it doesn't matter if they're labeled right or not. Okay, we were not getting BPDUs. Okay, and without getting BPDUs, switch 4 does not realize it's connected to a switch and that it does not see a reason to believe that spanning tree is needing a block port between these two switches because it doesn't see a loop because BPDUs are not coming in on this switch from this switch here. However, there was a loop which caused a broadcast storm. Okay? Now, what was happening is this data that was, let's say, packet goes down here, okay, and it comes back around into the switch, okay, which it gets resent back around into this loop, and again, and again, and again, and again. And what you will see is what you saw in the video. All your ports will start blinking at a very fast rate and congest your bandwidth to a streaking halt. Okay? So this shows you the importance of BBDUs. Okay, why is my delete button not working? And why is that not working? Wow. You know why? Because I don't think that was. Wait a minute. Is this on? That's in Notepad, not on my screen. That's why. Okay, so we need to go into here. Okay, and use this. Yeah. Okay, so that's why. That's kind of weird. I guess it was not looking at it from a perspective of OneNote. I guess took control over the drawing over the screen aspect. Okay, so now from that aspect, okay, we understood that. Now we caught this by doing a show CDP neighbors, where from the perspective, let's go back up here to draw again. Okay, from the perspective that we saw this switch here, okay, but no CDP was coming in this direction. All right, so we replaced this particular switch, all right, but it wasn't this switch that was the problem. It was this switch, okay? All right, now, whatever happened, we got to solve the issue, okay? Meaning that now BPTUs are coming across all links, and these 4 switches in the domain get to see span tree got to catch the loop. Okay, so for whatever reason, replace the switch 2, stop the broadcast, or switch 3, whatever. This particular switch here stopped the broadcast domain. I mean, I labeled these incorrectly, but it doesn't really matter. All right, so we replace this switch, and everything goes back to normal, and everything starts working. Now, okay, this is a design flaw that was due to hardware. Okay, the flaw, a design flaw doesn't mean it's your fault, and it doesn't mean always that it's your fault, and it doesn't mean that it's a flaw that could have been avoided. Okay, what we end up having was a hardware issue. Now, we got lucky to be able to see that. Okay, we could actually replicate this scenario by using BPDU filtering. Okay, what happened to wow? I don't know why it's doing that, but okay. I think we're going to stop using OneNote altogether, and let's just go to Notepad. Um, maximize this. I don't like how Notepad does this. Oh my god. What is happening? I don't know. I don't care. What is going on with OneNote? Why are these tabs still here? I just don't know. So, first of all, let's go into all programs. Must be Notepad's version for Windows 11. Not really liking it. Maybe I can change the settings later on, but for right now, this is what I'm looking for. Okay, so now OneNote's not in the scenario, so that should help us. So okay, so now our next issue was here is my PC, PC 1. All right, and in this PC I have VMware, and in that VMware instance, we have PC 1 and PC 2, This is our containers inside our PC, which are just virtual machines, right? Now, I have a bridge, to a physical network card, USB, coming out of here, all right? And this is bridged to this one, which will be NIC 1, NIC 2, and NIC 1. All right, and this is bridged over to this one. Now, this PC was 192.168.10.5, and this was 192.168.20.5. And not only were we not able to communicate and ping between these devices, even when these devices was able to be on the same domain, or broadcast domain, I should say. I'm sorry. That did not work because of the fact that we didn't even get ARP information. Meaning that the issue that we have here is the fact that somehow, even though, this, alright, we're going to hop over here, plugged into here and plugged into here, both in the same VLAN, VLAN 1, could not communicate with each other, alright? This is a VMware situation. This is another layer, which you know I don't like having other layers cause me problems, This is why programs like GNS3, can cause issues, Now, here's how that happens, You have a router, FAO1, FAO2, In the router table, we're going to say this is 192.168.20.1, 192.168.10.1. Now, so we're going to see this in the routing table. Connected, right? 192.168.10.1 in our routing table is directly connected, to FAO1. and 192.168.20.1, okay, is FA. Come on, we did this wrong. FAO and FAO1, okay, and this is also directly connected, okay, meaning that when something comes in FAO1, right, we can send it to the 20 network because we have an interface in there. Now, of course, our interfaces were VLAN interfaces, but it doesn't matter if it's a logical interface, okay, or a physical interface. It's still directly connected. All right. If it was an interface VLAN, it would show you connected 192.168.10.1. All right, is directly connected to interface VLAN 1. Okay, so now. Okay, so, all right, so what is stopping, if I can ping from PC1, okay, because you got to understand that that this particular router, even though it's in the actual VLAN, I'm sorry, in the routing table, okay, this information will also be in the switch of the routing engine, okay? Now, okay, my problem was if I'm on the same VLAN subnet, okay, my ARP request from PC1 to automatically hit PC2, which wasn't happening. Meaning now we have a layer, some type of layer that is causing this an issue. This could easily give you the idea that you have a bad switch. Okay, all right, but okay, knowing that the switch 9 times out of 10 is doing its job, okay, which again, all right, that statement is not the reality that we experience with the Spanish tree aspect, all right, but there is something going on, okay, all right. I eliminated VMware by deleting it and putting in VirtualBox, and that layer of VMware was creating that was failing was making me spend extra time troubleshooting a situation that I should not be troubleshooting. Okay? This is very important. So, just like having a complex a complex design, all right, like doing everything on sub interfaces. Okay, now you always have to make sure that the connections, your point-to-point connections, are going to the proper VLANs. Okay, that's an extra layer of extra complexity that's not needed. All right, so okay, this is the first time VMware has failed to me in that scenario. Okay, all right, and hey, but back to our GNS issue. Okay, so now we have our routes in here. Now, when you shut down a port here, this port, okay, should go down physically, okay? And that, my friend, is not what GNS3 does, because these connections are not physical, they're logical, okay? And they will always stay up. So if that's the case, even though I shut down this interface, if this interface is still up, okay, all right, I'm going to be sending traffic down an interface for a route that still comes up in my routing table, okay, because it did not shut down and remove that route from the routing table. This router still believes that this interface is up and live, and that's not the case. So that means you're going to be sending traffic down a black hole, okay, which shouldn't be, which is why I don't use GNS3 anymore. There's nothing wrong with using GNS3, okay? For its purpose, there's been millions of times I've been at work and only access to routers I had was GNS3, okay? But it took me days to figure out just what it was, and I had to be told what was going on because I was just learning CCNA routing, okay, at that point, and I was not good enough to figure out why this was happening. All right, I just knew that something was happening. that it wasn't supposed to happen. I don't know what it was. I think when I shut it down, my pings were still going. I didn't know, or what was happening, or whatever. It didn't matter. This interface did not go into a down status. The route was still in the routing table, and I was sending traffic down here. Okay, all right. Even though it should never have been, because with a real router, when you shut this down, this entry gets removed from the routing table because in order to have this as a connected interface, it needs to be up in the status and the protocol needs to be running. Okay? All right? So, so no longer do I need to use GNS3 because I don't want that extra layer of issues. Okay? All right? So, I take that off the table. Okay? Now, we take VMware off the table. All right? For whatever reason, all right. Even me having to go into administrative mode with VMware in order for my NICs to work, okay, that's just ridiculous. Okay, so automatically using VMware in the last couple of weeks, two issues that I have that I don't like. VirtualBox does not do any of these issues because why should it? Okay, all right. So these are extra layers that I'm talking about that I don't want us to spend time on. So, now, okay, so now from this scenario, we're going to have our redundancy here. Okay, so if switch 1 dies, okay, whatever else switch 1 is connected to, okay, let's say servers here. We'll just say a server farm, which would be a collection of, a collection of servers. Okay, if switch 1 dies, switch 2, PC1, PC2. PC1 and 2 can't get to the service, but they can at least get to each other. Okay? Alright? Now, Windows has gotten a lot more, and when I mean Windows, really it's companies that have gotten a lot more secure. Okay? Alright? The whole purpose of having Windows and a domain controller is sharing resources. Now, at one point in my career, okay, and I'm talking about like IT career back in 1994, and even the beginning days of my CCNA days, okay, which would be 2009. All right, working in that environment, okay, I could easily take a file or a folder, okay, and share it, okay, all right, and give it a name, Kyle. So anybody who's actually searching for my IP address, okay, all right, can find the Kyle file, share folder on their PC. All right, okay, and we'll be able to share information, files back and forth. Okay, now security has gotten a lot more tighter with companies nowadays, and this is no longer possible because they have disabled it in group policies. Okay, meaning that you can't do that. However, you will have access to a file server. Okay, where you can always upload files up there, okay, all right, but you got to create a folder, all right, which will automatically be shared to PC2, all right, and you have to upload the file into that folder on the file server, and just call your coworker and say, hey, go to the file server, blah blah blah, and this is where it's located in the Kyle folder, okay. You actually see too as a network engineer that everyone gets their own folder on the file server, or you just create it and just name it Kyle. Okay, regardless. All right, you have a means of sharing data, okay, with a file server, and eliminate the PC to PC file sharing. Okay, all right. Nothing's the only difference between that is the time it takes for you to upload the file to the folder yourself, instead of just right-clicking on a folder or a file and say share this file, or just throwing that file or copying it and pasting it into the file show the share folder on your PC. Okay, all right. To have more security, we eliminate that aspect. Okay, but what I want to mention though is, as an engineer, you need to understand why you're doing the things that you're doing. Okay, now this is in VLAN 10. This one's in VLAN 20. Okay, for whatever reason. All right, so now where do we assign this PC in its VLAN? And the answer to that is the closer to the source as possible. Okay? So that's why, as this switch is connected to other department switches, right? Okay? Switch 4, right? Okay? That's going to branch out to other buildings or other departments or whatever. Okay? These are what we call our core switches. Okay? Whether it's a core or distribution switch, these are your access switches. All right? And the moment PC1 sends data into out its network interface, it goes into a switch port, and that's where we want to assign our VLAN. Okay? If we want that VLAN to transform over to another switch, we make trunk links. We don't assign access switch ports, okay, because that's where I assign VLAN 10, and here I assign VLAN 20, and now PC1 can communicate with PC2, okay, because we made an error with our port assignments, all right? And what we have done is information that belongs in VLAN 10 has now have been bleeded into VLAN 20. We call it VLAN bleeding, okay? All right, so always trying to do your stuff as close as possible. Now, here's another thing, okay? So let's go ahead and in diagrams, okay? All right, you will see some people like to create VLAN pipes in a diagram, okay? And it will just be a list of pipes, okay, telling you all the VLAN traffic that it's carrying, okay? I'm not a fan of pipes, okay? All right, as far as wiring diagrams, all right, but at the same time, we can use color lines. This could be blue, this could be red, this could be orange, okay, and obviously they'll look like this, all right? One color for each VLAN, right? Okay, that's not orange, it's pink, but it doesn't matter, all right? Okay, or you can actually color the pipes, fill in this color here as the color of the VLAN in there as well, all right? However it is, I want you to understand the concept of what you're doing with a VLAN, okay? All right, so now, switch 1, VLAN 10. Okay, so this switch is going to go up to a switch up here, okay, over to here, okay, over to your server farm, which you have a bunch of servers sitting up here, okay, going across, oh, I'm sorry, going to another switch, which might be where your storage is, okay, all right, and maybe also connected over here, where your VMs are. Okay, now what we call end-to-end VLANs is the concept of wherever this traffic enters here, we need access to storage, we need access to VMs, and we need access to the server farms. Okay, so your VLAN traffic, okay, needs to reach from end to end. Okay, all right. So wherever you put your data in, which will be close as to the source as possible, we want to make sure that that VLAN is carried all the way across. Now, if these are trunk links, and we forget to add VLAN 10 to the trunk link, all right, that traffic will die. If the VLAN is not configured on that particular switch, let's say this has VLAN 101 and VLAN 20, all right, but it doesn't have VLAN 10. When this switch here gets that traffic across the trunk, it might be allowing that traffic to go there, but once it gets here, VLAN 10 is not there. So you configure it on the trunk to receive the data, but it's not, the VLAN isn't there. It gets dropped. Okay? It gets, technically, you got a black hole where the traffic will go to and then just disappears. Okay? So I just wanted to add that aspect of it. Okay? How you are designing your network, there's a reason for it. Okay? Now, this one is in VLAN 20. Okay, so you don't have to worry about, even from end-to-end concept, of VLAN 10 ever bleeding over into VLAN 20 if it is designed correctly. Mistakes happen, okay, but at the same time, that is your plan, okay? And we call it end-to-end communication, okay? For wherever source we're going to our destination, make sure your VLAN from source to destination is allowed, is configured on every switch, is allowed on every trunk, okay, so you can have end-to-end communication, okay? All right? So, our inter-VLAN communication, okay, was done like this. Okay, so first of all, we had to type in the command IP routing. Now, I want you to understand, a layer 3 switch that has the ability to route and act like a router is not something that is part of the switch, yet it is a added feature to the switch, meaning that you're taking a live router engine, okay, and placing it inside this switch. So when you turn on IP routing, you're turning on the router part of the switch. Okay? Now, remember that we have to have an active port in that VLAN in order for interface VLAN 10 and 20 to come up and function. Alright? Setting the default gateway to the inter-VLAN device, the inter-VLAN interface is the connection from the layer 2 broadcast domain of that VLAN to leave that VLAN through the interface VLAN of that VLAN number. Okay? Alright? It is this way out. Okay, so you need to have the interface VLAN 10 in order for that traffic to leave the broadcast domain of VLAN 10. Okay? Alright? So that is very easy to communicate between switch 1 and 2. Okay? Alright? Now, what if we are having multiple switches? Well, you gotta understand, okay? As long as layer 2 is communicating, switch 2, switch 1, alright, PC3, VLAN 20, okay? Alright, this is VLAN 22. Okay, so the interface VLAN will have, okay, will have its own MAC address. Okay, now as we have this trunk here, or I don't really care if this is VLAN 20, this is VLAN 20, PC3 will be able to communicate. Okay, all right, but even as a trunk, okay, you gotta understand whether they're in VLAN 20 or as a trunk. Okay, that MAC address is going to come over here. So when PC3, okay, has a default gateway of this interface, all right, it's going to ARP request that traffic, and it will come back with a ARP request. I would say ARP reply. Now, that means I can have VLAN 20 sitting on switch 1. Switch 2 is not routing, does not have IP routing enabled, but via layer 2 methods knows the MAC address of this interface and the default gateway, which is the IP address. So it will go in its ARP table, and I can still send that traffic from switch 2 to switch 1 and use VLAN 20 on switch 1 to get out of that layer 2 VLAN. Okay? All right? So, just understand why you're doing the things that you're doing. Okay? Your interface VLAN is to be able to communicate with other VLANs. All right? Because from that aspect, isn't that what you would like to do? Why have multiple VLANs just for isolation purposes, which you can do as well, and never have them communicating? Okay? But at some point, all right, you want that traffic to get out of that VLAN so it can communicate with other things like, hey, what about the internet? Okay? If I contain it in a VLAN, okay, and that internet is not a part of that VLAN, all right, keep in mind, a switch port can only be a member of one VLAN unless it's a trunk, which it can be a member of all VLANs. And a trunk does not have to be a member of all VLANs because we can deny, okay, certain VLANs not to be going across that trunk. All right, just like we can eliminate every one of them and have to manually go in there and add a VLAN every time we want that VLAN to go across the trunk. Okay, so I just wanted to review there and talk about the things that we've learned so far. We've had a lot of information we've gone through. Okay, don't worry, Spanning Tree is coming to return. Okay, just not at this moment. All right, and hey guys, be strong, be determined, be Cisco.